right, we're going to take a look at finding the limit as x approaches infinity of the quantity 1 plus 1 over x raised to the 3x. And I'm actually going to do this problem probably twice. Well, I'm going to do it once and then maybe do a second time afterwards. So first of all, right now what I have is kind of like a 1 plus 1 over infinity to the 3 times infinity. So kind of a hot mess. It's almost like 1 to the infinity, but it's not going to be 1 because this, as much as it's getting very, very small, is not actually 0. It just approaches 0. So where we're going to go with this is try and get it into an indeterminate form where we can use L'Hopital's. So while it's an indeterminate form right now, I cannot use L'Hopital's on it. So I'm going to do the limit, and this is one of those weird moments where I'm going to go limit as x approaches infinity of e to the ln of a power. Now this is using one of our log laws because we know ln of e to the x is equal to x. We also know e to the ln of x is equal to x. And basically I'm just using this log law backwards and saying, let's make it look more complicated because as I continue to go, that's going to help me in the long run because I'll be able to manipulate things. And you can actually see how 3 of my answers for this multiple choice have e in it, and this is where that e is coming from. So I'm going to, since I have an ln now, I can bring this exponent down. That's why I use that ln. Now right now, e is a constant. So for a moment, I'm going to look at just up here, okay? So I want to find the limit as x approaches this red expression, and that will give me my exponent. And my answer is basically going to be e to that power will be my answer because this blue base of e isn't going to change. That's not dependent on x. So I right now have basically infinity times 0. So I need to manipulate it as x approaches infinity. I'm going to go 3 ln of 1 plus 1 over x to the negative 1. So I'm using my negative exponents and basically unsimplifying things. And what happens now is if I put infinity in here, I get 3 times 0 on the top, and I'll get 1 over infinity. So I'm basically getting like a 0 over 0. Therefore, L'Hopital's applies. Since L'Hopital's applies, I can take the derivative of the top over the derivative of the bottom to work on this red limit. So I'm going to get 3 times 1 over 1 plus 1 over x times chain rule, negative, because this is x to the negative 1, negative x to the negative 2 over, this looks lovely, negative x to the negative 2. At this point, I can see that reducing because they're identical. So I'm not even going to try and simplify anything else. I'm just going to cross those two off. Get the limit as x approaches infinity of 3 over 1 plus 1 over x. As I place infinity in there, this piece is going to approach 0. So now I've got 3 over 1, which is just 3. That means way back here, since this was all just this exponent, this is really saying the limit as x approaches infinity of 3 to this power, or e to this power rather, is e to the third. Final answer, e. Now, you may have recognized this limit though from Algebra 2. This is a longer shot on this one. So the limit as x approaches infinity, 1 plus 1 over x to the 3x. Well, in Algebra 2, you first define e as the limit as x approaches infinity of 1 over 1 plus x to the x. That's e. So since this is raised to the third, this is like limit as x approaches infinity of 1 over 1 plus x to the x to the third. So we're really e to the third. That's if you recognize this limit, which some people do, some people don't. So 2 approaches, one using L'Hopital's, which was really what the question was looking for, but throw in another approach as well. Hope that helps.